So yeah, I'm Eddie Satterly. I do a lot of things all the time. So right now I'm a co-founder for DataNexus and for a company called Amar.ai and work with Slower with some of their clients as well as a partner. Been involved in open source for a very long time, longer than some people here probably have been around. Coming up on about 30 years of working in the secure data space. Started off with telcos and do lots of fun things. So I'm not going to spend a lot of time on slides. I have some slides to kind of drive conversation, but I hate talking to slides. So we've got the big, huge things, right? So when we talk about like the big challenges from the cloud perspective, right? And we'll spend more time on use cases than anything else, but these are kind of the big things. Like every client you talk to, and I'm working with 5 or 6 right now, actively, and a few more that are kind of in the emerging stages of doing this kind of stuff and moving not only their workloads to the cloud, but then doing interesting things like trying to figure out how to handle multi-cloud environments, how to handle some of my stuff has to be in the data center, some needs to be in a cloud. But the big things, deployment, like security, and both from the access perspective as well as kind of the secure pipeline perspective, like how do I take these complex different things and secure them? Containers, which is everybody's favorite topic of the day. We'll talk a little bit more about that. Compliance, which is the new big pain point for everyone who's trying to go to the cloud, is there's always somebody with an opinion on what they need to do to comply with a set of policies to go to the cloud. And then again, the automation component. So the key to pretty much doing anything anymore is if you don't automate it from the beginning, you're going to regret it for the coming future. So specific to the data side, because it's most of where I focus, but the cloud data challenges, right? We talked about the bigger challenges from like how do you get to the cloud? How do you get to multi-cloud or to data center and cloud? But when you talk about data, these are kind of the more drill down viewpoints of how that works, right? So end-to-end security. As I said, I've been in the open source community for a long time, Apache Cassandra early on, and several others just in the newer phase of stuff. But every single open source data tool has its own way of implementing security for no apparent good reason, other than the fact that that's how the engineers in that particular project thought data and security or end user security, everything else should be done. There's really no good way to pull that all together. So in some ecosystems, there's some tools that do that. If you talk about I'll use like a Hortonworks example. They pull together a Ranger and it does a whole lot of security stuff, but it's still very limited to their scope and ecosystem of where it plugs into. So when you start looking at solving those bigger end-to-end security problems, especially when you're securing a data pipeline or you're securing data that's coming in or going out from the company, again, back to that compliance conversation, is I need to make sure that I can say authoritatively that I'm compliant with whatever regulation we happen to be under, whether it's GDPR or the new California legislation or Singapore or Australia. I've had to deal with all of them in the last few years, and the more and more you get these data sovereignty kind of issues and the data movement issues, it becomes even more complex and challenging, and solving that problem is probably going to be the bane of most engineers' existence, and trying to figure out how to work with. I did a presentation at the Enterprise Linux Foundation thing not too long ago about legal and trying to get through legal and compliance conversations to even use open source, let alone deploy it and deploy your data there and do interesting things. There are a lot of legacy solutions in the space and a lot of SaaS and PaaS type of solutions that are around that have made this very interesting, trying to figure out how you tie this stuff together and how you handle the changes in format, the changes in data flow, all of these very interesting things, and then train your people at the same time on how do I do new distributed systems, how do I deal with clusters when cluster used to mean a master slave, and now cluster means no one's a master, and we have pieces everywhere. Huge challenge for a lot of the folks is to try to figure out how that all works together. The next one is obvious, but cloud choice, right? So obviously you can go to any number of cloud solutions, the big boys or some of the smaller ones. There's now even more popping up in the last few years that are very specialized and specific. And then, of course, you can always give Ellison more money because Oracle needs more money, so you can go to their cloud. And then the last part of this is really, in the what I will call the bane of my existence, is the talking about containers and how do we containerize stuff, right? For data, my first rule is don't containerize unless you have a really good reason. In the data workspace, you end up creating so many more problems than you have. So the majority of the data solutions that are out there use Java. They have a JVM, which is a virtualization layer, which now runs on top of a virtualization layer because you're using Amazon or GCP or Azure, doesn't matter. And then on top of that, you want to now talk about containerizing something and running another virtualization layer inside of the virtualization layer of your virtual machine. This is not a good practice. Don't do it, especially for high I/O applications. Right? When you're talking about data where you're moving data around, whether it's high speed or low speed, doesn't matter, but when you're talking about volumes of data that have to move, do not, just for the sake of it, inject yet another virtual layer into the solution. Now, that being said, we do a whole lot of things with virtualization. We do a whole lot of things with containers. So running management tier stuff on containers, running the monitoring tools on containers, running our orchestration tools on containers. Airflow, we run in containers, right? Those are all Amazon EKS or K8 native stuff. So there are places to use containers for high data workloads. Just because you can does not mean you should. So think about what and where, right? If there's a reason to do it, sure. Dev and sandbox, absolutely. Production, it will just inject yet another failure state capability into your data solution. Not the best choice. Also, there's always a bunch of emerging platforms. So I learn literally every day I talk to anyone in this space. I learn of some new startup somewhere doing something, or some solution that's been spun out of somewhere else that's doing some cool new data solution, some cool new cloud solution, security solution, whatever it is. There's emerging stuff everywhere. Companies should not jump on this bandwagon because they can. You need deep expertise. You need to understand it. You need to work with someone that can help you do what needs to be done. So do not assume that just because it's the newest, brightest, shiniest thing, which I like to call blog-driven development, which happens substantially within a lot of companies, don't do it just because you can. So look at ways to maybe try it, train on it, work with a partner to help you get there. You know, go to a SaaS or a PaaS-based solution first, maybe to try and see if you can get where you need to go. But if you're trying to do this internally, especially in, you know, bigger companies, it's just not going to go well. So it is worth your while not to jump into the emerging space until you have either the skills or expertise, or whether you go in with a partner or someone who can help you do it. These specific things that I'm talking about on this slide are probably 80% of the failures that I've seen within the clients I've worked with, and that's 40 or 50 in the last few years. From everything from very large, like Fortune 10, down to, small startups and tech companies. You still, just because you're a startup or you're smaller, does not mean you can do it. So, focus on the expertise and get the right people. So my approach and the stuff that's worked really, really well for the majority of the clients that I've worked with over the last 4 or 5 years is to think of things as a layered approach, right? Everything is a layer. And this goes back to my career started in telecommunications, and the layer model is a big thing in the telecom space, and I've kind of carried it forward with a lot of the newer things we do now. But if you think of everything as a separate layer, right? Whether it's, I picked blue and yellow to represent two of the clouds here. Not specifically talking about a vendor solution, but they probably map to like Azure and AWS, color-wise, right? But let's assume they could be any cloud. And when you talk about orchestrating an environment to make this kind of thing work for a data pipeline, right? You have to think of everything from the bottom up. How do I configure my network? How do I configure my cloud? How do I make sure I get public and private traffic separated? And on distributed systems that still use the zookeeper paradigm, public and private is really important. put your Zookeeper traffic on a private network. Do not route it. Do not leave it open. It causes yet one more way to make your system fail. And there's a bunch of others. But when you start looking at it, build everything up from the bottom, right? Think about what cloud am I going to use? How am I going to configure my network? Whether it's Amazon VPCs or VNets on the other side, figure out how you're going to configure that, how you're going to lay it out. Come up with a design. Deploy your VMs into a public and a private network. I know everybody says don't do it anymore, but use a frickin' Bastion host to get this stuff set up. Like, I know it's not the cool thing to do anymore, but it's the right thing to do to get between public and private networks and still protect the services that are not particularly resilient. When you deploy above a VM, it could be anything. Who cares what it is? In this case, I've got data stores and tools, but whatever you happen to be, whether it's monitoring, it's management, whether it's orchestration, whether it's anything, I don't care. Think of it as a separate component in your stack, right? That is a layer. You build that as a layer. And then when you stitch stuff together, that's the next layer up, right? So I want to take my Oracle database that's maybe running in my data center and move it to Postgres in the cloud because I don't want to pay Oracle any more money. Therefore, I'm going to do this. I'm going to use an orchestration, which is, we open source some stuff out of DataNexus for doing these data migrations. It's all in Python. It's sitting out on Git. But, it doesn't matter what it is. When you're orchestrating the movement from one to the other, think of everything as a piece, and then think of how you tie those pieces together. So I'm going to move all of my Oracle tables to Postgres. It's going from my data center to, cloud of choice or to RDS or whatever you're going to do. Think of the whole thing as stitching together a pipeline, and then make sure that you think of security kind of at every layer here. So how do I want to securely run my network? How do I secure my VMs? How do I secure the communication between the systems? And when you overlay all of that kind of security capability on there, then you don't end up having to go back and have conversations that are not fun with security organizations, compliance organizations, because you can say at every level, this is how I've documented, this is what I'm doing, this is the automation code that runs this is how I audit and test that it's run the way I said it was, and this is my pipeline end to end, right? It involves 12 systems, and those 12 systems do X, Y, and Z, right? So when you pull that pipeline thought together, and then when you have the consumers, right? Who's pulling data out, and I use consumer because, one, I spend a lot of time in Kafka these days, but just no matter how you do it, when you think of someone consuming that data, whether it's an application, a service, treat that as another layer, right? There's some app running on a VM that's consuming your data. I don't care what that app is. It may be another data store. It may be some custom code somebody wrote. It may be an analytics engine sitting out there. It really doesn't matter what it is. Think of that layer of the VM and app that's consuming whatever it is you're producing. If you're an API, it's consuming through an API. If you're a data store, JDBC, whatever it happens to be, think of them as yet another layer in the stack, right? It may be a layer you have no control over, and that's okay. But think of it as a layer. Treat them as a foreign client because you have no control over them. Assign them some client keys or however you're going to give them access. But think of them as a layer in your stack. This is probably one of the biggest oversights that I've seen going in and fixing broken toys that people have built is they don't think of who's consuming, how they're consuming, what they're doing to consume, and there's usually a lot of patterns they have not accounted for in their solution. It causes a great deal, more than half, of the issues that we've seen with these kind of platforms and pipelines running in production is that you don't think about, either you've made your producer external and you don't think about how they work, or you've made your consumption external and you don't think about how they work. And they've decided that a new pattern is really important without considering the fact that your platform wasn't built for that. You had a lot of problems with this early on in the Apache Cassandra space, because if you didn't know how you were going to be queried early on, someone could literally knock over your entire distributed cluster by writing a query that you were not optimized for. Right? Same thing was true in like Greenplum and some of the early MPP things. Is if someone decided not to use your query planner and decided not to use the patterns by which you built, and they write a 90 join wide query, they could literally knock over your really cool new MPP that costs millions. So whether it's the $1 million solution or an open source solution, if it's distributed or single node, try to think about your upstream and downstream components as critical parts of your stack and a layer that you may have no control over, but at least you need to pay attention to, right? And just instrumenting those layers is super important. And, like I said, it causes the majority of the errors that we see with clients in production. So I got a whole bunch of use cases. We can spend as much or as little time on use cases. And by the way, from this point forward, if you want to ask questions, just interrupt me now, because we can leave them to the end if you want, but we can also just ask as you go. I'm totally open to that and driving the conversations towards what you want to talk about. But these are kind of the big use cases that we see today that people are kind of going through and trying to implement these kind of data pipelines on top of, right? So sharing data between, clients and avoiding the risk and compliance conversation. I need to send this data to a client, however, I need to make sure we've redacted, PII level 1 and 2 stuff. No problem, right? Or I need to get data from third parties, but I need to make sure I never persist data that is a risk to me. We did some work for an insurance company a couple years ago. It's publicly available out there who we worked for, and we won some awards doing it. But we actually had to get a lot of data in, and they're in Australia, and we had to get a lot of data in from third parties that were not necessarily in Australia. And we had to make sure that anything we persisted to their environment did not violate Australia's data sovereignty and privacy rules, even though where it came from, the US for instance, where we have none, there was no rules about US people's data, but we couldn't persist US people's data to an Australian company without redacting things that violated Australian rules, right? So you don't think about that. You think about, the source allows it, so we could just pull it in, except you can't because it's a compliance finding and you have a problem. So we had to go and redact a whole bunch of data that we brought in from third parties that they were perfectly legitimately able to share as we purchased the data. They were allowed to share that with us. However, we were not allowed to, as an Australian company, persist that into our data stores without doing a disclosure, which means they would have to literally contact every customer that they were getting this data from in the US about auto claims. They would have to then contact each one of those US-based customers and tell them they had their data and that what the permissible use was that they were using it for. Clearly, we did not want to do that. It would have been quite painful because it was data on about 13, 14 million drivers that we did not really want to contact individually and explain that an Australian company was using their crash data to build risk models, right? So we just chose to redact that on the way in instead because that was a much better model. So even data coming in, when you think about it, sharing data out is obvious. Bringing data in, not maybe as obvious, but it is. And since we're talking about that, we'll talk about the next column, the IoT and telematics stuff. We also, for the same client, did work on pulling in data from apps and dongles in people's cars to give them better insurance rates, right? We've been doing it in the US for a long time. Almost every insurer now offers some way to share your data with them and do it in the US. They did not have that as an offering anywhere in Australia. They decided to pilot this. It was very useful. It was very useful for the client because they got a much better rate. It was very useful for them because they got a much better risk model. Except when we started looking at the data that was coming in, especially from the phones, not the dongles, but the phones, and the app that you install on your phone, the granularity of GPS data on your phone is down to a couple meters. In Australia, you cannot persist that data at a couple meters because that's personal information. So you have to not persist below 16 meters. So we had to go through it. Every GPS signal that came from the phone went through a cloud environment. Was not persisted in the IAG's environment. It was a cloud environment. We then redacted it there before we brought it into their environment and dropped off some of the last couple digits, so we lost the specificity of the area. And this came out of a lawsuit in Australia, which you can Google later, which was very interesting, about a guy and his mistress and finding out he was at a house because of the granularity of the data. And there was this lawsuit over a divorce. It was really fun. But this became part of Australia's privacy policy. So we had to redact data coming off of an app because, you have a great GPS on your phone. It can find you to very, very granular levels, which you can't legally store in Australia. So, those kind of things where you're talking about data coming in, someone's completely opted into sharing that data with us. Doesn't matter, I still can't persist it without disclosure. So we redacted on the way in. A lot of also what is becoming more and more important is the kind of live search and reporting stuff. When you talk about how do I want to see my data, how do I want to interact with it, it's really cool that I can build this BI dashboard, and Tableau makes it even prettier, and that's all great. But people don't want to do just that anymore. They've been spoiled, by Google and being able to search on something and be able to click through and find anything they want in a matter of seconds, right? So how do we get that search level persisted? Right? How do you kind of enable that capability and get data in near real time in a search index so that someone can do something with it? In the case of client, they use the Solar. You can also use Elastic, obviously, and we do a lot of stuff with monitoring and stuff in Elastic. But if you want to get live search, you need to enable that capability. You need to enable the security around it to make sure that stuff doesn't leak in. Another one of the really interesting things is we decided to bring in some call center data for another client and into their Elasticsearch cluster. And we were very careful to make sure the fields we brought in were like, name and ID and all these other things that were never going to have PII that we weren't allowed to persist into the data. And then we brought in the freeform notes field from the call center. What's super interesting about freeform notes field is you can type anything there. We did the first demo of this to a very small environment. Somebody types in some code they were looking for in the client type field, which was like 175 or something interesting. And all of a sudden here come up all these numbers, and a whole bunch of them are 16-digit numbers. And then we go look in the notes field, and interestingly enough, the call center had typed the person's credit card into the notes field because they wanted to make sure it went through, and they had their credit card number and their expiration date and the CVV for their credit cards all in a notes field in a live search. Luckily, it was limited to a very small number of users who could see the demo at the time, and we fixed that very quickly. But as it turns out, when we went to the call center to talk to them, there was actually a process written in their manual to tell them if it didn't go through initially to put the credit card number, expiration, and CVV into the notes field so it could be ran again later, which we, of course, fixed. Please don't put it there. Put it in the credit card field, and if it gets tokenized and it doesn't work later, we'll just call the customer back. We're not going to put their free form text all their information directly into the notes field of a call center record, right? So you see these really interesting patterns that emerge that, someone could have been exploiting that for years, and we might not have never known if someone hadn't actually tried to search and actually look at the data and see what was there. Now, probably wouldn't have got past compliance in their particular environment, but maybe it would have, and they would have had lots of PCI in-scope stuff sitting in a search system for customer service. So we've also been doing a lot of work on kind of the horizontal view of things, right? So with a lot of the new technologies, you can now look at things in a horizontal view, and they don't have to be very, columnar or very row-based. You can just horizontally look at what is all my interactions with this client. And this is one that we did, again, with IAG down in Australia, because they have about 50 years of data on their clients, because they have to retain a whole bunch of data, a lot more than we do here. So they've retained all this stuff, and we could go back and look at the interactions with some of their clients who had been clients for a very long time, and even descendants of clients where a business passed from father to son. We had that whole record tree, but they had never been able to view it in a horizontal view because it's all transactional based. They couldn't do that, so we built this capability out for them in a pipeline to be able to say, build the entirety of the interactions with this business who's our customer, and then every person related to it. So you could see in some cases it was the third generation business, and 50 years had been passed down to a new descendant. They had the same last name, or in some cases they did not, but they had the same hyphenated last name, or in some cases they didn't have the same last name at all, but we were able to figure out from other relationships that it was passed down through a daughter. But nonetheless, you saw this lineage of a customer that you would never have known, and you would never seen this relation by building this kind of horizontal view of stuff, which is now much easier to do. We also did a whole bunch of work with a medical claims company that was looking to optimize, be a back-end kind of, they're a startup, or they were, now they're a little bigger, but they were a startup that was trying to pull this data from a whole bunch of insurance aggregators and a bunch of hospital systems, and then do interventions in claims to try to reduce claims costs, both for the medical facility as well as for the person receiving care. And we had to do a whole bunch of really interesting feature engineering in stream. So this is one of the Kafka use cases, but essentially it's a ton of data. It's only mildly interesting to most people, and most of the data is completely uninteresting to anyone. But there are some key things that you really want to be able to pull out that mean something in healthcare. If you've got a healthcare background, ICD-9, ICD-10 codes, super interesting. Where somebody is at a given time, basis where they go for treatment, makes a really big difference. Whether they go to a hospital ER, or whether they go to a clinic or to a local doctor, makes a really big difference, both in your cost as a patient, but also specifically the cost of the insurer and the facility. So we did some really, really cool in-stream feature engineering to get stuff into there. They use Python Dask to build all of their models, and we could do live stream processing of claims and do real-time interactions. So you could literally log into your little doctor app and say what your situation was, and we would capture that directly from your interaction. We could feed it through their models, and they can immediately tell you, based on this is the preferred option for where you could go for lowering your cost as well as for getting the best treatment for the situation you had. So, that was a really kind of cool intervention thing. I wish we'd have been able to work with them a little longer, but at the time they were a startup, so money was the bigger challenge. But we got them to where they could do these kind of real-time interventions and show it, and they've grown it very, very large now. And then 2 or 3 of the largest insurers and 2 of the largest hospital groups now use them in the U.S. To do these kind of interdictions. Interaction methods, we kind of talked about some of those. Filtering and masking, we've talked about those. There's some really interesting things that we've done kind of on the masking and filtering side to help to forward data between regions and make sure that we comply with the PII 1, 2, and 3 stuff. The new teams and use cases. So this is one of those where we spent some time with a client, and they said, well, we've got all this data, but we can only let these people work on it because we have this data science team and we have this BI team, and they're the only people who work on our raw data, and then we eventually get a report or some output to a system, but that's the only way we can interact with our data. And we'd like to open this up to more teams, and we'd like to be able to do new use cases. And right now it takes us about a month to 2 months to do a report, and right now it takes us in data science about 6 months to actually produce a new output. And we told them that was not an optimal timing, and as had their business users for a long period of time told them that was not optimal timing. And so we worked with them to enable some kind of real-time data feeds where we guaranteed that certain data wouldn't exist because, again, we use the masking and filtering thing to say anything that looks at all like any of these at-risk rules, we'll just not persist any of it. If anything is in the field that looks like it might be a threat, so some people lost some addresses because they had like 7 or 8 digit street addresses. I'm not really sure why anyone would ever do that, but for some reason the street was long enough that they needed that many numbers in their address, and that became too much like it might be a credit card, so we're just going to make it the whole thing go away, and we lost some address fields. Not the worst problem they had, but it got them a lot of data a lot faster. So we talked about the feature engineering bit before, and we were doing some of that to be able to get stuff into their models faster, then to get output from their models, and again validate after the output of their models that there was nothing in there that was a risk, and then we could make it available to them to actually, in that case, we put it in JSON stuff and embedded it in a web page so that they could go in and do some searching and find some stuff and like play with it. Yeah, go ahead. Yeah, so specifically, like our platform, we built tools that do this just based on a regex. So we have a set of rules that it processes through, and we look for patterns and anything that matches a pattern that may be a risk, and then we work with the client to determine what other patterns they feel are a risk, because some companies believe certain data is a risk when everybody else doesn't, but it may be a risk to them, and they may see it. For instance, the insurance company had more people in technology risk than they had in IT. So because they're an insurance company and risk is what they do. So their risk organization was huge, and they had lots of opinions on what was a risk, right? And so we built very complex, very deep rules for that particular environment, because anything that might be or could be or maybe could be considered to be in the future, we'll just go ahead and redact it all now so that we don't have any risk, right? Versus other companies who are like, if there's not 16 digits in the number, it's probably not a credit card, go ahead and send it through, right? So you have very different views on what that is, but we do all that stuff in a rules processing engine. We've been moving all that stuff over lately. We've been moving it all over to KSQL and doing it on the Kafka side because it's faster. But we built an entire engine in Python to do that stuff with Regex to process all the data in stream, to basically use the Liberty Kafka stuff and build it that way. But you can do it many different ways. It's about understanding the rules. Yes. Yeah. So we actually are, like from a DataNexus perspective, we're a software platform, right? We work with partners and other companies who do consulting and use our stuff and white label it as well, or as an MSP. But we also do sell our platform to people. And in the case of IG, our platform is all left behind, and they use it still, and they use the base set of things that were built for them, and they built a whole bunch of other things since we've left that we have nothing to say about, right? So yes, it can be done in any number of ways. No, so the platform is all, for the most part, is all closed. We did open a couple of things that we built with clients that we've opened up. So like I mentioned, the one for the Python stuff that does CDC out of databases to migrate data, we built it with a client and they paid for it and we open sourced it. And we've expanded that since. It was originally just Oracle, and then we did MS SQL, and we've done some stuff with DB2 recently, and now mainframe DB2 we're working on now. So and that'll all be open sourced. The core kind of orchestration and automation components are not. That's part of kind of our proprietary thing, as well as the rules engine and all that processing. But we're built 100% on top of open source data stores, right? So we use Postgres, we use Solr, we use Elastic, we use Cassandra, we use Kafka at the core of everything. So it's a bunch of tools built around for security, ops, and flows of data around that. And then we built an entire cloud orchestration layer to help people basically go from on-prem to Azure or AWS or GCP, or move between one of the clouds, or move and split their stuff between the clouds. Or we did a whole bunch of stuff with Red Hat early on, so we have an OpenStack layer and an OpenShift layer, a little bit on top of that. And then we've recently built some Kubernetes stuff for Airflow and for some of the management tools. So like all that stuff that we build specific to the orchestration and component stuff, that's kind of what the core IP for our platform is. Yep. Any other questions, or should we just go? Okay, we'll do one more or two more and go from there. So the quick data retrieval things was really interesting that we found in a lot of environments that people build their own version, surprisingly, of how they interact with data, how they pull data, how they push data. They've each got their own little way of doing things, and they're usually they consider that their value to the company. So there's a whole lot of that, like build one-offs and do really specific things. And, this is my special thing that I built while I was here. And this is like this magical way in which we do business. And it really matters. And what we found is that most of that stuff never really gets shared properly, or it is not available to other people in other groups because they've secured it off or locked it away, or they will do it for you, but you can't do it yourself. So we've spent a lot of time helping people with doing more real-time data retrieval and more collaborative ways of doing things. It's not super easy to do a lot of collaboration in the space, but it is easy to open things up and let people have a look at things. And it's interesting that I've been working with one of the big financial companies lately, and they are incredibly siloed within each one of their operating units, and they all share the same pool of data. However, they all access different parts of that data, and they can only get to things that they have people who are able to develop the SQL or NoSQL or whatever capabilities to extract that data and pull it together, whereas we've helped them build a more rapid retrieval space, which is, again, that's built on Elastic, but it wouldn't really matter, right? I mean, we pull in an Elasticsearch and let them figure out what's there and let them play around with it a little bit and figure out what that data is and discover where it is. And then 90% of the time, someone's already built something that does what you want to do, and it's somewhere else already living in some environment, and we can get them there quicker. And they're like literally 3-year roadmap to do something, was offering very little value in small incremental portions, and like by accelerating stuff and getting this stuff into Elastic, we're done in less than 6 months with their next 3-year roadmap of things they were going to offer to their business units. And now we're trying to figure out what the heck we're going to do for the next 2 years, and trying to build this next new capability and next new something that gives them something to do, because you get this entire organization under a digital transformation office, and this is the set of things they promised in 3 years, and like we're now like at 6 months and we're done. So in the next 2.5 years, we're going to find something new and innovative to do. But like that's really just about letting people see what's there. And you had these, they said, well, the business users will never want to use this search interface. Interestingly enough, we set in a focus session with a couple of their business users and put them in front of an Elasticsearch thing and explained a little bit how it's not exactly Google, but it's kind of Google-ish. And you just need to use some little different terminology, and you got to use some things to make sure it's in or out, and it doesn't do a lot of stuff for you maybe that Google would do for you to assume what it thinks you want. But if you work through this, you can do it. And we sat down with some business users that were literally, one of them was the CFO of the company, and said, here, this is the kind of thing you can do to interact with your data. And they dug right in. As a matter of fact, there was this like 19-page list of requirements for new things they wanted that came out of a couple of focus sessions with business users in marketing and finance, and their sales and business development team, in their manufacturing team. These are business users who would never want to use a Elasticsearch interface. Interestingly enough, we exposed some stuff to them, and all of a sudden, it's the best thing ever, and they came out with 19 pages of requirements for what needed to come in the next couple of years, right? So this ability to make this and expose this to other people, and maybe you have to train them a little, but don't necessarily make the assumption that nobody wants to do it just because they haven't done it. And don't assume that a business user is not willing to use a search interface. If you make it available to them, they will help you. You may have to type for them a few times, because a couple of the people in one of the teams it was necessary for us to really spoon feed them. But nonetheless, they saw it up on the screen. They were super excited. It gave them new capabilities, new things they could do. So like, don't assume they don't want to do it. Another thing is the metadata stuff. I harp on this all the time, so I'm going to try really hard not to. But metadata is really, really important. You really need to categorize your data. You really need to try hard to store the data in a way where you can get to metadata about it to understand it. Because when you have to unravel that mess later, you end up with the same mess you have today, which is, ETL is your worst nightmare. And this makes some vendors very unhappy. But ETL is the very worst thing you could do to your data, because as soon as you transform it, you never get it back. Right? I used to do this talk, I don't know, a decade ago, that said ETL is an amazing tool at finding all of the gold you're looking for in your data. The problem is you weren't looking for the platinum and you left that on the floor. Right? So it's great that you got all the gold, because the gold is what you were searching for. However, the high value stuff you literally left in the hole. Right? And someone now has to follow you and try to recover that, or see if they can possibly reverse engineer that, or hope that the source system stores that data a really long time, and therefore we can go get it back later when we know we need it. And this is probably one of the biggest issues that like security team have with their data, right? Is that it's great that I can get access to all this data, but if I don't know I'm looking for it, it flows right through and gets dumped on the floor. And then I later go, I see this pattern now of this, hack or exposure or whatever else that I've just now started seeing in my data. How far back does that go? And then they go, in their Elasticsearch, they go back like a week, or in Splunk or whatever. They go back a week and they're like, that's what we have. Well, it's been going on for a week, but how long has it been going on for? And the answer is we have no idea, because we have a week's worth of data. Every 7 days we roll this over. So, we may have been hacked for the last 7 years. We have no idea, because we only have 7 days worth of data. Right now, it may have only been 7 days, it may have been 8 days, it may have been a month, but you have no way to reconstruct that. Right? So the more you can kind of tag the data for the value that it has, store it that way, and then make it easier for people to get to it over a period of time. Like, you can tier storage. Like, even in Kafka, we've been working with some of the clients to say, like, just use a Kafka archival cluster. Archive stuff off that's high value that you've metadata tagged to know you might need this later. It's not everything. If it's everything, you're doing it wrong. But it shouldn't be everything. It should be some subset, but store that, put it somewhere. so that you can get it back later and reconstruct the scenario and try to do as much EL and like not T as you can, right? Don't transform it if you don't have to. Load it, keep it. You may never use it, but you might need it someday. So try to do that as much as you can. And that's time for questions. So I will stop talking at you now. You can ask questions if you want up here. If not, you can catch me in the hallway and I'll answer questions privately if you don't want to answer them in public. So, any questions?
What kind of tools have you been using to store metadata?
Yeah, so the question is what kind of tools have you been using to capture and store the metadata side? So it depends. Where we can, I try to keep as much stuff in the Kafka store as we can and then write it off to wherever you need it for longer term. We've been very successful in getting clients to add headers to the data as it comes into the Kafka side so that I can tag it as to where it came from. We've also written some custom consumers and producers on the Kafka side to capture the system that it came from, like capture the IP address, and if they use a certificate, capture the public key of the message and where it came from so they know it's an authenticated session from a certain device, so I can at least tag it with that. So I know this came from a security device, or this came from a financial transaction system, or this came from, whatever it happens to be. So we sometimes cheat and add metadata to it if people don't give it to us, but yeah, we've been using a lot of Kafka to do a lot of that work too. And it's not ideal. And we have a client that's got an Informatica tool set. We got a client that's got a Talon tool set where they have that for us, and we're happy to just take that and consume it. But unfortunately, most people do not, at least in my experience. Or if they do, they don't know they have it. Some team may have it in the company, but they don't in the group we're working with. So, anything else? Okay, private questions in the hallway if you want, if you're too shy or afraid you might get in trouble for asking them on camera. All right, thanks guys, appreciate it.